This final video brought to you by Lego Bosick, Bounty Hunter Bosick. I'm not too familiar with him, but apparently he's a Star Wars guy. So now we're going to look at the composition of trig functions and their inverses, which gets a little tricky. So let's remind ourselves. So let's assume f of x is invertible, meaning it's 1 to 1, so it has a function whose inverse is a function. And then remember that one of the ways we prove that is we composed f and f inverse and got x. So in other words, we're plugging in, remember what the outputs of an inverse function are. They are the original inputs of the original function. So when we plug the outputs of an inverse function, when we plug an input into a function, we should get its output. And then switch the same thing around. So in other words, functions undo each other within their respective domains. So this is true when we compose things in this direction. Sine of sine inverse of x is just going to spit out x. That's for all x in the domain of sine inverse. Now there's special cases. Sine inverse of sine x equals x for all x in the range of sine inverse of x. Remember, we restricted the domains of these functions so that the outputs of these functions were not all real numbers like it was for sine. It was all values between negative pi halves and pi halves. So we have to be careful when we evaluate these. It may not be exactly just whatever we were inputting x. So we'll show that here. Okay, so I'm going to take the long view for this first one. I'm going to say, what's cosine of cosine inverse of x? Our claim is this is just the square root of 3 over 2. But let's make sure we know it's true. So I'm going to take what's inside here. And I'm going to say cosine of what angle theta equals the square root of 3 over 2? Well, from my memorized unit circle, I know that this is a first quadrant value. And I know that the x coordinate, that's root 3 over 2, which is the one that we want, is right here. And this measure is pi sixths. So then I'm going to take cosine of pi 6 and ask myself, well, what's the answer? Well, duh, it's that x coordinate, right? So yes, we've confirmed this is indeed the correct answer. Okay, so let's now do sine inverse of 1.8 and then sine of that. So this isn't a unit circle value. So I'll just grab my calculator. And do we want to be in degrees or radians? It doesn't particularly matter. I prefer radians, as most pre-calc folk will. So I'm going to do this in radians. I'm going to do sine inverse of 1.8. And that equals, go to, what? Domain error? What? Why? Okay, recall that what this is asking is sine of what angle theta equals 1.8. Well, what's the possible values of sine theta? If I look at my unit circle, the largest value is 1, and the smallest value is negative 1. So this is not a possible value, 1.8, undefined. Let's say that. Okay, so now let's try this one. So here we're saying, well, what's sine of 3 pi fourths? Well, sine of 3 pi fourths is equal to, well, I got to go to my unit circle for this one. I don't have it right off the top of my head. It's root 2 over 2. But let's see. So here's my unit circle. I know sine can be any value between 0 and 2 pi. Here's pi fourths, 2 pi fourths. Here is 3 pi fourths right here. I know that the x coordinate here is negative root 2 over 2. The y coordinate is root 2 over 2. So this output is positive root 2 over 2. Well, now this is the value of this input. So we're really saying, what's sine inverse of root 2 over 2? Recall that the outputs of sine inverse are only values between negative pi halves and pi halves. So root 2 over 2 actually shows up right here for our y value. This is positive, and this is positive. So the answer to this is not 3 pi fourths, because that is not in the range of sine inverse. It's pi fourths. Note that these have the exact same y values in these two places. Okay, let's do our last one here. So what is sine of pi halves? Well, sine of pi halves happens to be, if I use this thing, it's 1, right? I could use it up here as well. So then what this really becomes is, what's cosine inverse of 1? recall that the range of cosine inverse is all values from 0 to pi. In other words, we're fixed in the first and second quadrant for our possible outputs of the inverse function. So where is it? It's at 0. 0 radians. This is where x is 1. Note pi is where x is -1.